Alright guys, this is going to be Chapter 1 review, pages 4 and 5, odds. Starting with number 35, it says, what is the coordinate of the midpoint of EH? So from E to H right there, what point is in the exact middle? So I know the distance from E to H is going to be from negative 2 to 14. Negative 2 to 0 is 2 spaces, and then 0 to 14, that's 14 spaces. So I know just the length of EH is going to be 16. So if I take the midpoint, then I want that 16 to be divided into 2 equal pieces, which is going to give me 8. Now, that doesn't mean that the midpoint would be at the number 8. What that means is that it would be 8 spaces from negative 2. So, like we did on the first page, you can draw in all your numbers and work with the hops. 3, oh goodness, I'm going to run out of room. We're going to make this one 4, 5, 6, 7, 8, and so on. And you want 8 hops from negative 2. So that'd be 1, 2, 3, 4, 5, 6, 7, 8. Notice we land on the number 6. That's 8 spaces from negative 2, and it'll be 8 spaces back to 14 as well. That's how you know it's the midpoint. It's the point in the exact middle. So if we go back up to our number line, number 6 is on the G. So the coordinate is 6, and I would also write that's point G. The next section is all about angles. So look at number 37. And like I said earlier, we have a lot of rules in geometry that you have to know rules in order to set up your algebra. So in this case, number 37, the rule is that whenever there are angles right across from each other, that you get to set those equal. These are called vertical angles. It's a sign for angles. Vertical angles are always equal. So you set 6x plus 2 equals 3x plus 26 and solve. Minus 3x on both sides. Then minus the 2. You get 3x equals 24. Divide by 3, so you get x equals 8. It only asked us to solve for x, so we know we are done. Number 39, when you look at that, we can't set them equal because we don't know that they are. There's no vocab word to tell us. But what we do know is that together they make this 90-degree angle. So we're going to add them and set them equal to 90. Probably the biggest mistake here is sometimes people just assume that they're equal. And you can't do that. You really have to know it. So 3x plus 8 plus 2x plus 7 equals 90. Combine your like terms. 3x plus 2x is 5x. 8 plus 7 is 15. Subtract 15 on both sides. So 5x equals 75. Divide by 5. So x equals, I think that's 15. Yeah. Number 41. We don't know that these two angles are equal, and you know what? They don't even look equal. This one looks really big compared to this one. So I can't just say, hey, they're equal, and I'm going to solve. So I got to look for another rule. And this picture shows me that together these two angles make a straight line. So like we learned in class, that means they're going to add to equal 180. So we say 11x plus 6 plus x plus 30 equals 180 degrees. And that's that straight line right there. That's how we did that. Combine your like terms. 12x plus 36 equals 180. Subtract 36 on both sides. So 12x equals 144. Divide by 12. Sorry. So x equals 12. Moving on to the next page. Still working on. We're going to get into the distance formula. You will not have to have this formula memorized. It will be on the board for you. But you want to take your x's and subtract them, then square, then add y's subtracted, so y1 minus y2 squared. Notice there's a big square root over it all. That's probably the part that students miss out on. They leave that square root off, so don't do that. I'm going to go ahead and label my points, x1, y1, x2, y2, and I'm going to plug them in. The square root of -2 minus a -4 squared plus y1 is -1 minus y2 is 3. Notice that the formula itself has that minus in it, and my x2 is -4, so that minus a negative turns into plus a positive. From there, I'm going to combine like terms in the parentheses. -2 plus 4 is 2 squared, plus -1 minus 3 is a -4 squared. Whenever you have that negative squared, you want to put that guy in parentheses. 2 squared is 4, plus 4 squared is 16. So I add those guys together to get the square root of 20. Now pay attention to what the directions say. If they say round to the nearest tenth, then you want to put this in your calculator and round it. If it says simplified radical form, then you want to simplify the radical. And how we do that is by breaking it into factors. 5 times 4, and then 4 breaks up into 2 times 2. You can circle those 2's. They get to break out of jail. Whenever you have a buddy, that's when you get to get out of the radical jail. The 5, he doesn't have a buddy that looks just like him, so he has to stay in. So 2 breaks out, 5 stays in. I always say that 1, 2 stays right outside of jail, the other one goes home. Just kind of my way. The 4 right here, he has been broken down into 2 2's, so we ignore him, and we ignore the 20. So my answer is 2 radical 5. That's the simplified radical answer. We're going to do that same process for the next one, x1, y1, x2, y2. x1 is 6 minus 2 squared plus -4 minus 4 squared. Then we add what's inside our parentheses. So you get 6 minus 2 is 4 squared. -4 minus 4 is a -8 squared. 4 squared is 16. -8 squared is 64. Add those together to get the square root of 80. Simplify that radical. I'm going to break it up into 8 times 10. 8 breaks up into 4 times 2. 4 breaks up into 2 times 2. 10 breaks up into 2 times 5. So I've got 2, 2, and 5 stuck in. 1, 2 comes out, the other one goes home. So that's that one. 1, 2 comes out, the other one goes home. And then a 5 is stuck in. When you have multiple numbers on the outside of the radical or multiple numbers on the inside of the radical, they multiply. So you get 4 radical 5. (47) is very similar because it wants us to find AB, and when it looks like that, that means the distance. So we're going to still use that distance formula. And it wants us to find the midpoint. Oh, you know what? I just went back and read the instructions for 43 and 45, and it said find distance and midpoint as well. So we can do that. Our midpoint formula is when you add the x's and divide by 2, and then you add your y's and divide by 2. So add the x's for number 43. You get -2 plus a -4 over 2. Add the y's, -1 plus 3 over 2. So -2 plus a -4 is a -6. Divided by 2 is a -3. -1 plus 3 is 2 over 2 is 1. So this is my midpoint. Then my number 45, add the x's, 6 plus 2 over 2, and then add the y's. So 6 plus 2 is 8, divided by 2 is 4. -4 plus 4 is 0, divided by 2 is 0. So that's my midpoint for number 45. Sorry about that. So we're going to do distance and midpoint again, but on the graph. It's not really different, they just want you to find your own coordinates. So for instance, A is at -1, +3. And B is at +1, -1. Then we label our points, x1, y1, x2, y2, and we plug it into that distance formula again. I don't have a lot of room here, so I'm going to do this work down at the bottom of the graph and try and write small. So square root of x1 minus x2 squared plus y1 minus y2 squared. Notice that turned it into a minus a negative, which makes plus a positive. So -1 minus 1 is a -2 squared, plus 3 plus 1 is 4 squared. So you're going to get 4 plus 16, which we already said was the square root of 20. And we broke 20 down into simplest radical form up here. So I know it's 2 square roots of 5. So that's my distance. Then midpoint means I need to add the x's, divide by 2. So -1 plus 1 over 2, comma, add the y's, and divide by 2. -1 plus 1 is 0, divided by 2 is 0. 3 plus a -1 is 2, divided by 2 is 1. So that's your midpoint. 0, 1. Notice we do write it in parentheses with a comma in between. Right. Number 51 tells us to measure the angle to the nearest degree. So I'm going to get my protractor. And like we said in class, this hole that's in the middle of the protractor needs to go on the vertex of the angle. And if you notice, the protractor has these lines right here at 0 and at the hole. They need to be like level with the angle. So if you see here, this line is not level with the bottom of the angle, so I know that my degree is going to be inaccurate. Another way to make your degree really accurate is to extend this top line so that it crosses your protractor perfectly. So I line up that vertex on the point and I make sure that my protractor is level, and I see that it comes out to about a 44 degree angle. It's a little less than 45. You might be wondering, how do I know that it's 44 instead of 136 degrees? And the reason is because when you look at this angle, I know that this angle is smaller than 90 degrees. And so that's why I choose the small number that my protractor's crossing over. Not the 140, because it's not an obtuse angle. This is acute. Okay, that's it for pages 4 and 5 on your Chapter 1 review. Please let me know if you guys have any questions.